Good afternoon to all of you. This is Dr. Neelam from Department of Chemistry, Sri Sankaracharya Mahavidyalaya, Junwani, Bhilai. I am going to deliver my lecture on the topic of carbohydrates. Carbohydrate are the polyhydroxyaldehyde or ketones. Their general formula is CxH2OY. This substance that form on hydrolysis and possess at least one chiral atom. Classification of carbohydrates. They are classified on the basis of hydroxide products. They are classified into three categories: monosaccharide, oligosaccharide and polysaccharide. Monosaccharide is they are the simplest carbohydrates which cannot be hydrolyzed to smaller molecules. For example, glucose, fructose, galactose. Oligosaccharides are the carbohydrates which hydrolyze to give 2 to 9 molecules of monosaccharides. They are also classified as three categories: disaccharides, trisaccharides and tetrasaccharides. For example, sucrose, maltose, lactose and raffinose. Polysaccharides, these are carbohydrates on hydrolysis give large number of monosaccharides. For example, starch, cellulose, gums and resins. Reducing sugar and non-reducing sugar. Those sugars which reduces tolerance and failing solutions are called reducing sugar. For example, all monosaccharides and oligosaccharides except sucrose are reducing sugar, but non-reducing sugar, with those reagents, those substances do not reduces tolerance and failing reagents are called non-reducing sugar. For example, all polysaccharides. Anomers are epimers whose configuration differ only about carbon 1. For example, alpha D glucose and beta D glucose are anomers, and alpha D glucose and beta D fructose, alpha D fructose and beta D fructose are anomers. This is the example. Epimers, diastereomers with more than one stereocenter that differ in the configuration about only one stereocenter are called epimers. For example, glucose and mannose at carbon 2 center, glucose and allose at carbon 3 center, glucose and galactose at carbon 4 center are epimers. Structure of monosaccharides. All form of aldose or ketose may exist in open chain form as well as cyclic form. In cyclic form, pyranose refers to six-membered ring. This refers to del linkage, since hemiacetylic linkage between carbon 1 and carbon 1 and carbon 5. This is the cyclic structure. And the furanose refers to five-membered ring is formed. This refers to gamma linkage, hemiacetal linkage in between carbon 1 and carbon 4 gamma carbon atom. Haworth representation. The OH group in Fischer projection on the right hand side are shown below the plane of the ring, and those on the left hand side above the plane of the ring in Haworth projection. And this is the example of Haworth projection. Now chair form conformation. Haworth projection structure are transformed to the chair conformation. The OH group which are below the plane of the ring in Haworth structure are also placed below the plane in chair conformation. Now the glucose. Glucose is the most common monosaccharides which is found in nature in free as well as the combined state. Preparation of glucose by acidic hydrolysis of cane sugar. If sucrose is boiled with dilute acid in alcoholic solution, glucose and fructose are obtained in the equimolar ratio and by enzymatic action. Glucose is obtained by the hydrolysis of starch by boiling with acid at 393 Kelvin under pressure. Starch in the presence of di-stage enzyme, it gives maltose, and maltose gives glucose in the presence of maltase enzyme. Now the chemical reaction of glucose. Glucose react with hydrogen cyanide to give glucocyanohydrine and react with uh, hydroxylamine to give glucooxime, and glucose react with phenylhydrazine to give glucophenylhydrazone, and more number of phenylhydrazine react with glucose to give glucoosazone. Glucose react with tolerance reagent to give silver mirror test, and Fehling solution and Benedict solution also give the red precipitation with glucose of cuprous oxide. Now glucose react with nitric acid to give glucaric acid, and glucose react with periodate to form per formic acid and formaldehyde. Now glucose react with red phosphorus and HI, which is a strong reducing agent, to give normal hexane. Now disaccharides. The disaccharides consist of two molecules of monosaccharides. When hydrolyzed with enzyme and dilute acid, they give two molecules of monosaccharides. For example, maltose on the enzymatic hydrolysis to give two molecules of glucose, which is joined by the 1,4-glycosidic alpha linkage. Sucrose on the enzymatic hydrolysis to give glucose and fructose, which is joined by the alpha 1 and beta 2 glycosidic linkage. Lactose on enzymatic hydrolysis to give glucose and galactose, which is joined through 1,4-glycosidic beta linkage. Now polysaccharides. Starch. Starch is a natural polysaccharides. This is a structurally different polysaccharides, amylose and amylopectins. Both are composed of glucose units. The amylose molecule is made up of D-glucose unit joined by 4 alpha glycosidic linkage between carbon 1 of one glucose unit and carbon 4 of the next glucose unit. The number of D-glucose unit in amylose range from 60 to 300. This is the structure of starch. Now cellulose also a polysaccharides. Cellulose is a linear chain natural polymer of beta D glucose joined by 1,4-glycosidic linkage. This is the cellulose structure. Now thank you.